Hi everyone, welcome to your channel Impulse Tech. I am Yogesh Bhavne. So today I have come up with the interesting video, that is IoT based smart garden. Based on the soil moisture sensor data, we are going to control the pump. So let's get started. So I have already logged into my Blynk IoT platform. Now here you can see the templates that I have created already. For creating a template, you need to watch my previous video. So I'm not going to create here a template. I'm going to do few changes in existing template. So I'll click on this data monitoring and I'll just click on edit. Now I'll just rename it. I'll rename it as a IoT based smart garden, or you can write IoT based smart farm as well. It's up to you. So I'm building this for my garden. Give the meaningful name to the template so that you will understand that what. So select your device and Wi-Fi connection type. So we have given the description. You can choose your own image. Now the most important part, we need to add the data streams. So here you can see we have already added the data streams for temperature, humidity and potentiometer data and the LED. So here we need to do the few changes. Let's see what are those changes. Let's click on pod data. So instead of pod data, we'll write here moisture sensor or SM sensor, soil moisture sensor. So I'll write SM sensor. Okay, so instead of pod data, we have written here SM sensor. So the virtual pin is we have selected is V2 and the data type is integer. So SM sensor gives us the maximum value of 4095 because it's an analog sensor and the ESP32 has 12-bit resolution. So here we are going to do the automation based on the soil moisture sensor. So for that we need to go to the advanced settings and we need to expose this particular data stream for the automation. So we have already done this. So you need to click here, like just click on expose to automation and select here sensor and click on save. Now let's click on this LED. Now instead of LED, we are going to control the relay here for turning on the pump. So I'll write here relay, so that we will understand that why we are used this particular data stream. So we have used here virtual pin 3 and the data type is integer. You know that we need to turn on and off the relay. So we have used just 0 and 1. If you want to do the automation, so let's go to the advanced setting and expose this particular data stream to the automation. And here you need to select the switch because relay is a switch. So relay is a kind of a switch. So just click on expose to automation, go to the switch. So now we have created 4 data stream. One is for temperature, humidity, soil moisture sensor and the relay. Now we will add one more data stream for monitoring the light intensity inside our garden. So let's click on virtual pin and I'll write here light sensor. Okay, so let's select the color. So I'll select yellow color of sun and the virtual pin is V4 and select the data type as a integer, and here you will get the maximum value of 4095. Okay, and click on advanced settings and go to the expose to automation. Click on that expose to automation. If you want to do the automation based on the light sensor data, then go to the sensor and click on available in condition. Now click on create. Now we have created total 5 data streams. Let's click on save. Let's click on update one active device. Okay, now go to the web dashboard. Here we need to do few changes. So here we have added temperature, humidity, potentiometer data and the LED. So we need to delete this LED, pod data and this chart as well. So let's connect your humidity here. Now let me add one more gauge for light sensor. So just click on that. So click on setting and the name of the gauge is light sensor, or you can write the light intensity here. and choose the data stream light sensor So select the color and click on save. And we need to add here switch. Let's add the switch for controlling the relay. Let's click on setting and here we'll write relay, and here we'll select V3. So for on value it should be 1 and for off value it should be 0. So let's click on save. So we are having temperature, humidity, light intensity and the relay for controlling the pump. So let's click on save. Okay, so we have successfully configured the web dashboard. Now for configuring the mobile dashboard, we need to go to the mobile app. Now we will configure the mobile dashboard. So here you can see on the screen the same template is there inside the mobile phone, that is data monitoring with automation. So let's click on that. Here you can see there are 2 templates. Now we will configure the mobile dashboard for our project. So let's click on setting. Just click on the particular gauge. So what I'll do here, I'll write here SM sensor and select the SM sensor here. Go back. So I will not touch temperature and humidity because it's already created. So let's click on LED. So instead of LED here, let's write relay and select relay here. Okay, so it's a switch basically, you can see. Let's go back. So now we need to add one more gauge for monitoring the light intensity. So let's click on these 3 lines and search for gauge. So let's click on gauge and click on that gauge once again and write here light intensity and select the DataStream light sensor and select the color you want and go back. So here you can see we have added temperature, humidity, SM sensor, relay and the light intensity. So now we have configured the mobile dashboard. So now we'll see the circuit diagram of this project. So this circuit diagram looks quite complex, but for understanding the circuit diagram you just need to go step by step. First connect your DST11 sensor, then connect light sensor, then connect your soil moisture sensor and then connect your relay. So just go step by step, you will understand. So now here you can see your DST11 temperature sensor has 4 pins. Out of that 4 pins we are going to use 3 pins only. So every sensor has VCC and the ground common pins. So here you can see VDD, that is VCC. It is connected to VIN pin. So VIN pin basically gives the supply to this VCC, and the data pin, which is the output pin for us, which is connected to the digital pin 13 of the ESP32, and the ground pin is connected to the ground pin of the ESP32. So here you can see I have used this R1 1 kilo ohm. So this you can consider this as a soil moisture sensor. So soil moisture sensor also has the ground, VCC and the analog output pin. So here you can see what I have done. The output pin is connected to the analog input pin 34 of the ESP32, and one terminal, that is ground terminal of soil moisture sensor, is connected to the ground. Here you can see I made the common connection for the ground, and the another end of the soil moisture sensor is connected to the VCC. Here you can see 3V3 pin. So this R2 is nothing but the light sensor. So I have created the voltage divider across the light sensor. So the output of that voltage divider is connected to the analog input pin 35 of the ESP32. And here you can see I made the common connection between the 3.3 volt. And the another end of that particular LDR is connected to the ground. So I will share this circuit diagram inside the description box. So here you can see the LDR, another terminal is connected to the ground pin. So you can consider the LDR as a voltage divider circuit. So if you don't understood anything, just feel free to ask me inside the comment section. Now let's connect the relay for controlling the pump. So here you can see relay also has 3 pins on this side, VCC, ground and the input pin. So VCC is connected to the 3.3 volt. So your relay may not get triggered on the 3.3 volt. That means your relay will not on 3.3 volt. You need to use the 5 volt supply. So you can use V in pin or you can use the external 5 volt supply for turning on the relay. So this is the ground pin. It is connected to the ground pin and we have used here digital pin 15 for controlling the relay. On the right hand side of a relay, you can connect your pump. So now this is the most important part of this project. So I have not done any changes previously and I have not even tested this circuit. So I am doing this with you guys. Let's see what changes we need to do. DST11 sensor is connected to the digital pin 13 of the ESP32 and the type of DST sensor you are using is DST11. So here you can see I have declared one pin, that is pot pin. So in my previous video I have connected potentiometer to the analog pin 34. So now what we write here, SM sensor, SM underscore sensor. So now soil moisture sensor is connected to the analog pin 34. We have defined that, and also we need to define one pin for light intensity sensor. So light sensor, we'll write here light sensor, light underscore sensor equals to 35. So it is connected to the pin number 35 semicolon. So here inside the data stream you can see relay is connected to the virtual pin 3. So relay is nothing but the switch. We need to turn it on and off. So for that we need to write this virtual pin. So here inside the code, what I have done, we have used here blink underscore write for turning on and off the relay. So here I have defined one variable, that is pin value. So here in pin value variable we are going to store the 0 and 1. So whenever you toggle that particular web dashboard, then it stores that value inside the pin value variable. So what I have done, digital write 15 pin value. So if you turn that toggle on, then pin value becomes 1 and you can digitally write pin number 15, as you know that you have connected your relay to the pin number 15. Now here we can see inside the void sensor function we are reading the temperature and humidity data by using the Blynk sensor library. So here you can see we are storing the value of humidity inside the H, and for temperature we are using the T. Now here I wanted to store the value of soil moisture sensor as well as the value of light intensity. So here you can see I have defined one variable, that is pot value. So instead of pot value, what you can write, soil sensor, or you can write moisture sensor. So I'll write moisture underscore sensor. So moisture underscore sensor is equal to analog rate pot pin. So instead of pot pin, you know that what you have defined earlier, you have defined SM sensor. Let's copy this, Control C, and paste it inside this analog rate function. Now define one more variable for storing the value of light sensor. So I'll write here light underscore intensity equals to analog read opening and closing bracket. Let's copy this light sensor, Control C, and paste it here, semicolon. Now we are storing the value of light sensor inside this variable, that is light intensity. Now we need to do few more changes. So here you can see we are writing the values. So blink.virtual write. So where we have used V0 virtual pin for temperature, V1 virtual pin for humidity, V2 virtual pin for pot value. So instead of pot value, here we will write SM sensor. So right here soil moisture sensor. So we have used V2 pin for soil moisture sensor. If you don't know about it, so go to the DataStream and you can see here V2 we have used for soil moisture sensor. I have used here SM sensor. You need to use here moisture sensor because we are storing the value inside this moisture sensor. Let's copy this and paste it here. So you know that light intensity or light sensor is connected to the virtual pin 4. So right here V4 comma and the light intensity variable name. and semicolon. Write the values inside V0, V1, V2, V4 and V3 we have used for relay. So I have used this line of code for event logging purpose. So if you want to learn about what is event logging, you can watch my previous video based on the event logging. So right now I don't use that, so I have commented this line. Now inside the word setup, you need to tell that the pin number 15, that is relay pin, is the output pin. We have done with the programming. Just this simple part we need to modify. So I need to compile this code because I have not compiled it already. Let's see whether it works or not. Let's click on verify. Code is successfully compiled, there is no error. So now let me connect my device and upload the code. So I've connected. So now let's select the port. So the port is already selected, and so let's click on upload. So whenever it says connecting, you need to press the boot button. Let's press the boot button. So now you can see the code is uploading. Device is connected. Now let's go to the platform. Let's go to the devices. Here I have already added the device. So let's click on that. Now here you can see the light intensity value is changing. Now here you can see the temperature, humidity and the light intensity data. So now what I'll do, I'll try to increase or decrease the value of light intensity. Let's see how can I do that. So I'll turn on my flash. You can see I have turned on my flash. Now I'll try to increase or decrease the value of light intensity. You can see here, you can see the value of light intensity is increasing. Whenever the light is more, its value is also increasing. So I'll decrease the value. So here you can see. So here I have not added the soil moisture sensor. We need to add that as well. So just add gauge, click on setting, right here, moisture sensor, and select the data stream, that is SM sensor, and select the color, click on save. And here also you need to click on save, click on update one active device, and here you can able to see the value of soil moisture sensor. I will just insert this soil moisture sensor inside the water, and you can see the output on the screen. So here you can see the moisture sensor data. So as you can see, whenever I insert the soil moisture sensor inside the water, you can see the output on the screen. So this is my setup. You can see on the screen DST11 sensor, your soil moisture sensor, and the relay for controlling the pump, and the light sensor. Now we will set up our automation based on the moisture sensor data. Now you can see this moisture sensor data is 4095. That means it is not inserted inside the water, or you can say the moisture level is, the soil is very dry. So for this purpose we need to turn on our relay, right? So now the relay is turned on. Now what we need to do, if there is more water, we need to turn it off as well. Soil moisture sensor inside the water, and the value is 2063 or 2053 something. Let's go to the automation. So now we will create automation from the scratch. Let's click on create automation. Now select here device state and choose the device, data monitoring with automation. The template name is not changed here, I don't know why, and select the options. So we wanted to use here soil moisture sensor. So here you can choose the condition from the drop down, that is less than or equal to, or is equal to, something like that. So now here you know that whenever I inserted the soil moisture sensor inside the water, the value is 2063, right? That means there is a moisture, so we need to turn it off. So here we will select is between. So we will select here the value is in between 2000 and 2063. So you need to select the action. So we need to control the device. Let's click here, and we will control the relay. So we wanted to turn it off because the moisture level is high. So here you can see the off is there. So let's click on save, and the automation name is smart pump. Okay, let's click on save. Now we will create one more automation for turning on the pump when there is a less moisture. So what I'll do, I'll just select whenever the value is greater than. select the value is greater than, that is if it is greater than 3500, then only we wanted to turn it on. So let's click on save. Now let's go to the devices and see the value. Now the value is 4095, that means it is greater than 3500 and there is no moisture. That's why it turns on your relay and the pump. So whenever there is a more moisture, you can see the relay is turned off, that means your pump is off. As you can see, if value is more than 3500, it will turn on. If the value is in between 2000 and the 2063, then it will turn off. And this is how you can create the automation inside the Blynk IoT platform, and you can create your own IoT based smart garden. Here you can able to monitor the light intensity, humidity, temperature and the soil moisture sensor data of your garden. So this is the cool project that you can build for your garden. So if you like this video, then do subscribe the channel and like the video. Thanks for watching.